Hello everyone, welcome back to another video of Bare Metal C. Yay! Woo! So in this video, it's going to definitely be shorter than last video. Last video was 45 minutes last time I checked. In this video, it's going to be more straightforward. We're not going to make too many in-depth things regarding like the data sheets and all that. We're just going to be reading kind of just like pins, right? So, and by the end of this video, I want to just be able to do what you see in front of you right here. So here we have the same circuit from last time. So it's just the LED connected to PB1 through a current limiting resistor. And then we have this blue LED in the same configuration, but it's just one pin below it, which is PB0 or D8 on the Arduino. And then we have a little button here, which is going to be a new one. And this is connected to PD7, which is one more below PB0. And I'm just going to put this to the side. So I show you what is the schematic and what it actually looks like. So here what you see is the schematic or the individual circuits for the breadboard. So this is what it looks like for the first one. It's connected to PB1. Here it's connected to PB0 to ground. And then this one is connected via a switch. And then it's going to ground. Okay. And I'll get to this diagram later at the end of the video. So, and these resistors are 330 ohms. I already stated that you can use like 2 or like 150 all the way up to even 1,000, but the brightness will be much, much lower. So yeah, this is the circuit. So if you haven't already done that, you could just make that. And I'm going to go to the code now. I'm going to increase this brightness a little bit. There you go. So I'm going to go back to the code and we're going to start beginning the code. Oh, actually, I didn't even show you what I want to build. So what I want to build is this. Okay. So whenever you press the button, it turns on the LED. And notice how, because we're using non-blocking tasks, that LED can stay in a blinking state, and I can press this as much as I want. Look at that. I can press it as fast as I want, as long as I want, and it won't interfere with the blink. So I don't know if you could time it if you want, but that will always blink at exactly 1 second. So 1 second on, 1 second off. Okay. So that's the circuit, and that's the end goal by the end of this video. So let's go to the code. So back to the code. All right, this is a very familiar spot. So we said that we want to turn on another LED. So we have to make another output, just like you would with the Arduino IDE. So let's do that. Let's create an output. It's connected to PB0. And now we set this one to PB0. Let's try to connect our button. So what do you do when you want to connect the button? So the button, let's think of it, is connected to ground. So let's put it at an active high state. Okay. So let's set it at an active high state. First of all, the button, is it an input or an output, right? If I ask you if it's an input or output, it should be obvious that it's an input, because you can think of inputs and outputs as the following. If you're sending a signal from your computer outwards, such as turning on an LED, it's going to be an output because you're never receiving data from the LED. You're only exiting that data, right? You're sending a signal high. But a button, actually, you want to read that signal. So how do you write an input? So you just do ddr ampersand is equal to tilde 1, and this is PD7. Okay, this is PD7. So this is the button input. Now we know that the button, by the way, is connected to ground. Okay, so one of the sides is connected to the Arduino and the other side is connected to the ground. Since it's connected to the ground, it's going to be inactive low when you press the button. So what does that mean? That means we want it that we need PD7 to be active high so that we actually can tell the difference whether it's on or off, right? So to make a pin active high is just like turning on an LED. So, oh, I made a little mistake up here. This is group D. Let's correct that. And so it's port D. It's equal to 1 PD7. Okay. Now, I have to remind you, you cannot do this if you have an output. Okay. If you have an output, never have a pin like a button connected to ground. That means that if you're turning on that button and it's connected and it's set as an output, that means that you're essentially just shorting 5 volts to ground, and that can damage your board. So because we're setting it as an input, it's not actually sending 5 volts to the button. What this line does, it's setting the pin from group D and bit number 7 to high. So it's going to say, hey, this pin is naturally high, and I'm going to read from it, and it should be naturally high. So we're not setting 5 volts, we're just setting it as active high. Okay. So let's go into our while loop. Now, a new thing we're going to add below our if. So this was from last video. It's the blinking sketch. So this is how it's blinking. And below it, we're going to put an if statement. Okay. And in the if statement, we're going to put the way we're going to read the pin. Okay. Now, the way we're going to read the pin is by putting pin D ampersand 1 PD7. Okay. So what does this do? So this line checks the state of digital pin 7 by isolating it, by isolating its bit in the input register. Okay. And the expression, so this expression right here, creates a bit mask with only bit 7 set. Okay. So just like I said in the first video, it only sets the first bit as high. Then it does an AND operation. And what this does, it checks the active states. So this is like a live, it checks like the live values. Okay. So it's live. So this will always be updated automatically. So this by itself has like an internal interrupt somewhere. Okay. And probably like an AVR library in here, likely in this one or in this one. So this one will always check the internal interrupts, which one is high and low. So the state. And this is the if statement. So it will check whether or not this is true or false, since it's an AND operation, right? It's doing an AND operation. And so, okay, let's imagine this. We've just pressed the button. This is going to be low. This is going to be high because it's active high. That means that this whole thing will be false. But since we're doing an if statement, it can only be executed if it's true. So what do? You put an exclamation point. You put an exclamation point, and this is a Boolean negation. So instead of using a tilde, so a tilde like this, so a tilde like that, what it'll do, it will essentially say, hey, flip every bit and I want to see the output. While the exclamation point is a bit mask test, meaning it'll just check that single bit. Okay. So that's a very important thing. Whenever you're doing if statements, it's very important that you use exclamation points when you're doing your negation checks. Okay, it's just checking for a single bit. A negation is an operation. Okay, the tilde is an operation. This is not an operation. It's just checking. Okay. So when you get false here, it means that your button is now pressed. And if you do the negation operation of that, it will become true. So this will be executed. And so you can say, hey, let's turn on that LED. Port B. One PB0. Okay. So this will turn on the LED. Otherwise, we'll just turn it off. Oh, and if you want to turn it off, you put ampersand, tilde, P, B, 0. I cannot type right now. I don't know what's happening. I think it's my keyboard's language. So this will turn it on. This will turn it off. And vice versa, right? So let's test this. I'm going to upload this. Actually, let me just switch screens real quick. Okay, I'm going to upload this by pressing the arrow. I'm going to go to cam. And there you go. It says that it is uploaded. So let's press the button. There you go. Look at that. It's working. And I can press it as often as I want, as fast as I want. Okay. Very nice. Okay, so that works. And there's a lot of things you could do with a button. You can do a lot of practices in bare metal C with just buttons and the way the LED works and how it's functioning. So that's done. We're able to accomplish the goal of this video. And I want to just do another thing, right? I want to go through the idea of a debounce, okay? So implementing a software debounce. So you may have already heard. So you may have already heard of debouncing. Debouncing is occurs when you want to kind of stop a bounce from occurring and like happening in your system. So this is what we call a bounce. So this is called a switch bounce. So when you press a button, it doesn't go into an active high state or low state immediately. Okay. So that doesn't happen in the real world because it's a physical switch, right? You're physically pressing the contacts together, and it takes some time for that contact to fully, to fully occur. So this part right here is called a contact bounce or a switch bounce, and it's a high noise state. So there's a lot of noise in that period, and if your code specifically starts running at like every tick, it's definitely going to start detecting that noise. So what we do is we implement a debounce either by hardware or software. Now, a common way of adding a debounce in hardware is just adding a capacitor. This will remove all the high frequency and whatever low frequencies from that signal. So depending on your system, you can either have a high or low frequency as your bounce, as your switch bounce. So a debounce capacitor, it'll just remove that, or rather it will smoothen it out. Okay. In software, however, what we do is, hey, instead of reading from the beginning over here, let's start reading like right around here. And if you know the duration of time it takes for this bounce to last, you can just tell your software, hey, let's just start reading after 2 milliseconds, 3 milliseconds, 10 milliseconds. You could do that. And because we've implemented system time last time, we can use that property right here. So what I'm going to do from last video is I created a few variables. So I've created last blink time and last press time. So last blink time is the same variable as the last video, except I just added the word blink. Okay. So instead of it being just last time, like last video, I added last blink time. And here I just wrote last blink time as well. So these two were replaced with last blink time, and I've initialized it here. And then I also added, in this case, last press time. So just take this value and we're going to use it to create a non-blocking delay for a debounce, software debounce. So what do? You write if, and you do the same thing. Current time minus last press time is greater or equal to, and a debounce can vary in time, like how much debouncing you want. So you can wait, for example, 4 milliseconds, 5 milliseconds, and then you put your code inside of this. So a debounce is essentially a delay, right? So you could technically add like a delay before like this. So you can add a delay like here of 5 milliseconds, but we don't want that. Don't get used to that. This is blocking. You're not doing anything, right? For 5 milliseconds, this will do something with the blink, right? Technically, this will no longer last the blink duration. It's going to last 1,005 milliseconds and so on. So don't use delays. Only use delays, by the way, whenever you're doing like there are some use cases for delays. Uh, a use case would be, for example, things that require motion. Servos sometimes require delays because you don't want another system or any system to be online if a servo that has a critical task is moving. If the servo, let's say a motor, is moving and there's something else, like a sensor grabbing data, and when you don't want it to, you could add a blocking delay. That's fine. But usually in these sort of scenarios, you don't want to use delays. So if the current time minus last time is greater than 5, in this case, we're talking about milliseconds, then execute this. And where do you put your recursion? So your recursion occurs here. You put last press time is equal to current time. And that's it. We're able to implement a debounce as well as just a button to turn on your LED. Cool. Well, let's go over to our camera. I'm going to upload this. I'm going to go to cam only, and I'm going to remove this, bring this back. And there you go. So it's uploaded, and I'm going to just press this. There you go. So what you won't notice it right now, but in the software now what's happening is that it's waiting 5 seconds and then it's checking. So every 5 seconds checking the state of the button. So yeah, so we've just essentially just added a successful debounce. So I hope you enjoyed the video. This video was shorter than last time, but it's still a very important video because we were able to read off of a pin. Next video, I'll think of what I'm going to do. I think I'm going to stick with a couple of button examples, maybe even add a button where like it just keeps on and stays on, and start implementing Booleans. And then afterwards, we might implement PWM and ADC readings and so on and so forth. So I hope you enjoyed the video. Comment down below what you think, what you want to see, and yeah, see you guys later.